Here we have problem 3 from the January 2020 CXC Math exam. In part A, we are given the diagram of a hexagonal prism. We want to count the number of faces, edges, and vertices. So we're going to start by counting the vertices. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we have 12 vertices. Next, we're going to count the number of edges. Edges are the lines connecting the vertices. So here we have 1, 2, 3, 4, 5, 6. The hexagon in the back gives me an additional 6 edges. So we're at 7 edges, 8, 9, 10, 11, and 12. Then in the middle, connecting the two hexagons, we have an additional 6 edges. So we're at 13, 14, 15, 16, 17, and 18 edges. So we have a total of 18 edges. Finally, let's count the number of faces. Faces are regions enclosed by the edges. So we have 2 hexagon faces in the front and in the back. And then we have faces connecting the 2 hexagons. So in the middle we have 1 face, 2, 3, 4, 5, and 6. Then counting the hexagon in the front and the hexagon in the back gives me 7 and 8 faces. So we have a total of 8 faces. And that's the answer to this problem. In part B, it says that a sports club owns a field PQRS in the shape of a quadrilateral. A scale diagram of this field is shown below. 1 centimeter represents 10 meters. In the following parts, show all your construction lines. The field is to be divided with a fence from P to the side RS, so that different sports can be played at the same time. Each point on the fence is the same distance from PQ as from PS. In part 1, we're asked to construct a line representing the fence using only a straight edge and compass. So the important thing that we're going to use here is this fact. Each point on the fence is the same distance from PQ as from PS. I'm going to start by drawing a line from P to the side RS. Now take any point that's on this line. Say this point right here. Let's call it X. Now let's draw the distance between X and the side PQ. And label this point Y. And let's draw the distance between X and the side PS. Let's label this point Z. So notice that we formed 2 triangles here. Triangle PYX and triangle PZX. Notice that the angle here at the vertex Y is a right angle, and also the angle at vertex Z is a right angle. And we also know that both of these triangles share the side PX. If the angles YPX and the angle ZPX were the same, then by the angle-angle side property, we would be able to conclude that triangle PYX is congruent to triangle PZX. And that would force the length XY to be the same as the length XZ, meaning each point on the fence is the same distance from PQ as from PS. So, our goal here is to construct a line that bisects the angle at the vertex P. So let's do that construction. Take your compass, set it at any length you want, and place the center at point P. Then draw an arc intersecting PS and PQ. We'll label these intersection points A and B. Then take your compass, place the center at A, and draw an arc near the middle. Without changing the length in your compass, place the center at B and draw another arc near the middle. This new intersection point we'll label C. The line that we draw from P through C will bisect the angle at P. So that's the line that we're looking for in part 1. Now, to do part 2, all you have to do is take your ruler and measure the length of that red line. If you measure this red line, you will find that the length is 7.5 centimeters. The problem says that 1 centimeter represents 10 meters, so to convert from 7.5 centimeters to the actual length of the fence, we multiply by 10 meters per 1 centimeter. The centimeters cancel out, leaving you with 7.5 times 10 meters, or 75 meters. And that is your final answer for part 2. In part C, we have two quadrilaterals, PQRS and its image P'Q', R', shown on the grid below. Part 1 says, write down the mathematical name for the quadrilateral PQRS. Since QR and PS are parallel, we say that this is a trapezium. In the United States or in Canada, this shape is called a trapezoid. In part 2, PQRS is mapped onto P'Q', R', by an enlargement with scale factor K, about center C at point AB. Using the diagram above, determine the values of A, B, and K. To find the center, we can draw lines through corresponding points and see where those lines intersect. For example, I can draw a line through Q and Q', then draw a line from R to R'. I see that there's an intersection point, and that intersection is the center for this enlargement. I can also draw a line from P to P', and those three lines intersect at the same spot. This point of intersection is the point -4, 1. So in part 2, the answer for A is -4 and B is 1. To find the scale factor K, we just compare similar edges. For example, we can compare the length of PQ, which is 1, with the length of P'Q'. And looking at our diagram, we see that that length is 3. So it seems like my scale factor K is 3 because the lengths were tripled. We can double check this by comparing another pair of edges. For example, PS has length 2. If I compare that to the length of P'S', we see that that length is 6. So again, the length tripled, so our scale factor K is 3. So those are the answers to part 2.